This is for the 4.8 notes for honors geometry. It's called Use Congruent Triangles. So up until today, or what we've kind of been working on for all of Unit 4 so far, is how do we prove these triangles congruent? And so the quiz yesterday kind of covered all of those different triangle congruences. There's 5 in total, right? We know that we can use, I'll write them at the top here, SSS congruence, SAS congruence, let's do AAS congruence, ASA, and then these are all 4 that work for any kind of triangle. Specifically, we don't need to know anything specific about them. They can also work for right triangles, but RHL we know only works for right triangles. You can't use RHL when you don't have a right triangle present. But remember, right triangles might use RHL or might use one of the others. So now that we know how to do that, though, we kind of take it one step further today, and what we'll kind of keep picking up on even on tomorrow. So it says what we're about to do is use something from your yellow sheet that uses the idea that once you know the triangles are congruent, we can do more with that. So it's something that we actually had kind of looked at earlier. It says if triangles congruent, then all corresponding parts congruent. So we did kind of look at that earlier, like the first day we talked about when we were looking at, I think it was a 4.2 or 4.3, where we saw triangles are congruent, so let's label all of the corresponding sides and angles, and we listed them all out. So that's kind of what we're doing here, but now we're going to do it with proofs. So it says in a proof, we can use the definition of congruent triangles to prove other statements that are true about the triangles. So it says if triangles are congruent, then corresponding parts are congruent. Okay, so here's the shortcut, or like what's in your proofs packet. I'm going to highlight this because this is what you're going to always use as your reason on the proof, because that's what it says on your packet, or on the yellow page that you have. So the wording for proof sheet says if triangles congruent, then are all corresponding, and it's abbreviated, it's fine, parts congruent. Okay, so I'm going to highlight that because that's what you want to use on a lot of these proofs today, even for homework. You got a new packet, just do 4.8 homework on that packet. Okay, so we have this new theorem or definition that we're going to use in our proofs, but here's the key part. This is so important. Make sure you prove a pair of triangles are congruent first in order to use this statement at all, this reason at all on a proof. You have to actually have first used one of these 5 triangle congruences to actually show some triangles are congruent, and then this would be the final step that kind of shows you something else. So let's walk through this one together, and we're going to do just a proof here, and then even for the rest of the notes actually are really short. It's just this whole portion here, and then there's just practice problems, because that's what you're going to do. You're going to keep practicing this, and eventually next week on Monday or Tuesday we'll have like more practice time with it, because tomorrow after we do this lesson we are working on 4.9, which also has more things we can do with proofs. Okay, so let's mark this diagram up. First of all, the given says GK bisects angle FGH and angle FKH. So you have to look at which angles it's referring to, because those are both going to be divided into 2 congruent angles. But again, we don't know this yet, so we don't know really anything. So we're going to mark with our diagram, but I'll do it with a highlighter, or you can use like just knowing that that colored pen or pencil is something I need to still show. Same thing for those. And then finally, I should hopefully see the reflexive property too, because we've been working with that already, and that's another thing. So it looks like for my plan, I'm going to be able to show these 2 triangles are congruent with ASA. So I kind of like give myself some notes off to the side here. That's going to be ASA congruence, and I have to first show that the angles are congruent because of the definition for bisects. I have to show reflexive property, but then I can show what my triangles are. Now here's the tricky part. It's not going to tell you which triangles to prove congruent. All it's going to say for the proof now is parts of the triangle. So let's see which parts we want to work with. FK is what we're trying to show is congruent. So I'll do this. FK is congruent to HK. So we're trying to show that these parts of the triangles are congruent to each other, and the way we can show that is, again, by proving these triangles are congruent. So if you wanted to like write the letters out for yourself right now, you could do that, just to kind of give yourself an idea of what you're going to be writing. So the triangles that we're going to show are congruent, so we need to first show that these triangles are going to be congruent. So I'm doing FKG is going to be congruent to HKG. Just again, notice how I'm matching the letters with the rings around it. So if I went to F, that corresponds to H. K has the same angles, and G here has the same angles. So that's how we know which ones relate to each other. Okay, so let's do our given. GK bisects angle FGH and angle FKH. Okay, and then number 2 here, I'm going to do the definition for bisects, which is on your yellow sheet. For angle specifically, make sure you're reading the right one. If angle bisected, then divide angle into 2 congruent angles. All right, and now we're going to write down which set of angles. You can do the same reason for the for 2 statements, right? We have 2 statements we can write here because we're working with 2 sets of angles. So I have angle FGK. If I'm writing FGK, make sure you match the letters, so I would write HGK. Okay, and then we have the second set also. We have this one on the left, so FKG, and then that would be HKG. Okay, so far I have 2 angles that I have found in my proof. Okay, and now we want to go on to step 3, which is the reflexive property. Okay, and so for the reflexive property here, we want to see which side is reflexive to itself. So it's KG, and notice it's going to be KG for both. KG is congruent to KG. We're not switching any letters because notice the rings around, you're counting the same order, 2 to 1 and 2 to 1. And then finally, now that I have 2 sides at an angle, 2 angles and a side in the right order, I had angle, side, angle, because that was my plan. That's what I wanted to do, and now I can write out the 2 triangles that I wanted to prove congruent first, because again, like we said at the top here, make sure you prove a pair of triangles congruent first, then you can go on to do anything else with that. So FKG is congruent to HKG. And finally, for my step 5 now, and these proofs are not lots of extra steps, but they can be more. Now that we've shown the triangles are congruent, we use that same reason that's up here that I highlighted. If triangles congruent, then all corresponding parts congruent. And now you get to pick any part of the triangles that were congruent. You could pick anything at all that will help you prove what you're trying to prove, which in our case is FK is congruent to HK. And now that I've said that for my last step, I'm done. That's how I know I finished this proof. So that's kind of the idea. What I'm going to do now is kind of still work out the answer key is posted for like all of the rest of these, but it'd be great if you tried them first and then looked at the answer to see if you're doing them right. I'll also kind of work through the answers real quick on this so we can pause the video, and then I can give some hints and things like that as you, well, let me give the hints first and then you can pause the video after that. So for number 4, example 1 at the bottom here, where it says 4.8 practice, and you're just kind of trying to think, what is my plan going to be? First, you want to mark everything up. It's already kind of marked on here. It's just hard to see. So those tick marks include 2 of the sides. Now hopefully you see the third side is the reflexive side. So this is not too much, harder to get to show that the triangles are congruent. So again, you're going to show the triangles are congruent first. So you need to show triangles are congruent. And if you need help writing out the triangles, here's a hint on that. It should be CAB. If you're writing that one as CAB, then the next one will be DAB. But you could have written yours different, of course. Now, once you find that the two triangles are congruent, and remember, we already kind of have an idea it's going to be SSS, then the goal is to show that segment AB bisects CAD, segment or angle CAD. CAD is here. So we need to actually show, in order to use this statement or get to this last statement, we need to show that angle CAB is congruent to angle DAB. If I can have that as like my second to last step of the proof, then I can use the reason that helps me get to this bisects. Here's where the reason was. It's if angle divided into two congruent angles, then angle bisected. Okay, so we're going to try to use that for the last reason. But go ahead and try this one out, and then I'll also have the proof written here. So you can pause it and kind of try this out. There's two more on the next page also that do more of the same thing. Again, the more you try out, the better will be good practice for you. I'll actually talk through some of these tomorrow as well. So try them out, check the answer keys if you'd like to. I just don't want you to take up too much time in class where I'm talking and telling you how to do them rather than you trying them out. So go ahead and take the rest of the hour to work on these, and also you can start on homework. And then tomorrow I'll go over numbers 1, 2, and 3, all of them actually, because I'll have the answer key and walk through each of those. Okay, so go ahead and get started. You shouldn't have to pause or unpause now. We can just end the video here.